Alright, so when you are going to start solving for your problem, always start state by state. So in this case, you can see that I start with the state 1, and that given state 1 is 27 degrees C. So you change it into Kelvin, so plus 273, so it's going to be 300 Kelvin. This is very pretty direct, right? And then next, what about your state 2? Right, so if I'm going to enlarge over here, okay, for state 2, we are going to solve for isentropic first, where you have this T2S over T1 is equal to P2 over P1 and K minus 1 over K. So you make use of these equations, isentropic equations, isentropic process equations. Please refer to your notes in chapter 5 regarding, in chapter 5 regarding Brayton power cycle. So T2S is, you rearrange back these equations. Where do you got this 0.4 over 1.4? Because K minus 1 over K, where you have the value over here for air, right? You are going to have a constant specific value Cp, Cv, R and K for air. Okay, so you rearrange the equations over here, and then let's see what do you get down here. So this is the result for T2S, right? So where is your T2S? Your T2S actually is here. Okay, if I may rewrite it back, your T2S is here. Okay. Okay, next, once you got your T2S, remember that you have the isentropic efficiency for your compressor over here. So you need to find for the actual value. So you make use of this isentropic efficiency of your compressor, which is work of isentropic divided by work actual. So you have this Cp T2S minus 1 over Cp T2A minus T1 is equal to 0.82. So what you do actually is you rearrange the equations back, and then let's have a check over here. You can cancel out this Cp term over here, is because it's the same value. And next, that you already find the T2S value. T1 is already given. 0.8.2 is the efficiency of the isentropic. T1 is already given, so you plug in all the value and it will give you T2 actual. So where does this T2 actual sits? So this T2 actual is actually at this state over here. Alright, so next, if we have a look at your sequence over here, so we already obtain your T1 is already given, T2S is already found, T2A also we have calculated. And what about your T3? T3 is also given over here. Now we are trying to look for your T4S and also T4A. So when you solve your problem in sequence, after you got your T2A, now that you are going to state again your state 3 over here, which is 1300 plus with your 273, so you are going to have 1573 Kelvin, right? So next we are going to solve for the isentropic state at 4, which is state 4S. So you are going to make use of these equations. Please bear in mind, where do you get these equations? You can retrieve these equations from your textbook or also your notes in Brayton cycle, which is in chapter 5. So you have this isentropic compression from 1 to 2, and also you have this expansion 3 to 4. Okay, where 3 to 4 is happening at your turbine state, 1 and 2 is happening at your compression state. So you make use of this equations arrangement, and you rewrite the equations in your solutions. Alright, so once you have rearranged, please remember to write down the value actually before this one. So you are going to plug in your T3 is actually 1573 times with your pressure ratio is 8, so this is 0.4 over 1.5. Then only you come back to this value over here, right? Please do not leave this step. I have made a mistake over here that I left this step over here, so please you in solving for your own, please include this step over here. So in next part we are going to look for T4A.